Hey, hello, differential equations. So I thought you might need a little more Laplace help. What's this called? Laplace transform help. It's getting dark out here. I hope you can see. It's midnight. No, it's not midnight. It's just cloudy. So this shows up on your quiz a couple of places, and so I just made up another example like this. So yeah, you try looking this up, you can't look this up. It doesn't look good. And this doesn't factor, sometimes this factors into a couple linear factors, and when it factors into linear factors, that's lookupable. I don't have it right here. But anyway, so on some of these you have to complete the square. So now, it's kind of easy, to complete this square I need a 9. So one way to get a 9 is to take this 12, is to make it s squared plus 6x plus 9 plus 3. I just took that, that 12 and made it a 9 plus 3. But anyway, now I have a perfect completed square. The numerator is 3s minus 7. That's a little complicated. But let's move on down here. So this is, I'm trying to do a Laplace inverse, by the way, a Laplace inverse of this. So the denominator now is s plus 3 squared plus 3. So that's a sine or a cosine that's been sort of shifted. I mean, that's not the right word, but it's been multiplied by an e function where you insert this s plus 3. So this is a sine or a cosine depending on what the numerator is. Well, when the numerator is a number, it's a sine. When the numerator has an s, it's a cosine. I've learned that by looking at these tables millions of times. But if the numerator is an s, by the way, I have both. I have an s and a number. But if the numerator is an s, it needs to be an s plus 3 now, because it needs to match this up. So I'm going to make this s an s plus 3. Now, what the hell did I just do? Hang on. I just made this an s plus 3. So in a way, I think I just added a 9. I just added a 9. So I should go over here to this 7, and I should subtract a 9. I added a 9, and I should subtract a 9. So now I have two separate Laplace inverses here. I have the 3, s plus 3, over this denominator, s plus 3 squared plus 3. And then I have a negative 16 over s plus 3 squared plus 3. And then I can look these up. So these are in the table. I'm sorry, I don't have my table with me. Damn it. I think it's 19, 18, 19. But I actually know what they are. I know that this is a cosine, square root of 3t, as that's k squared. And with this s plus 3 inserted where the s usually goes, means it's multiplied by e to the negative 3t. Now there's one other thing. There's a 3 multiplied out front. So I just did the Laplace inverse of that. There it is. And I think it's 18 or 19. This one is a cosine. This one is a sine. Again, it's a sine, square root of 3t. That's the k. It's got an e to the negative 3t in front of it, multiplied by it. That's what happens when the s plus 3 is inserted for the s. And then it needs a square root of 3 on top. So you pull the 16 out, you put a square root of 3 on top, and then you divide by a square root of 3. And so I just did it. We did the Laplace inverse of this guy. That's kind of complicated. Listen, while I got you here, but I think that shows up a couple of times on your first little quiz or your first Chapter 7 assignment. So maybe that helps. I think the last video had one example of this in there. So here it is again. And while I got you, I'm going to explain something else to you. This does not show up on your quiz yet. It might show up on the next quiz. But when you're trying to do a Laplace, I'm just making this up, 5s minus 3 over s plus 2, s squared plus 4. When you're trying to do a Laplace inverse of something like this, and it might show up in the future, You know, I've been able to look up most of these things or manipulate so I can look them up. But damn it, this one is never look upable for me. And what your book points to a lot of times is it says, man, you got to do partial fraction decomposition, which we haven't done in a while. That's been Cal 2. Maybe we did a little at the beginning of this course. But this particular dude with this linear factor and this quadratic factor, I always try to look him up. I can't find him. I can't look him up. And so I have to do some partial fraction decomposition. Let me just remind you how to do that. You go off to your scrap paper and you make an A over an S plus 2. You make a BS plus C. I'm not kidding, it's not BS. It's a BS plus C over S squared plus 4. That's how you handle the quadratic factor. And then and this is out of the Laplace inverse. This is just this decomposing this fraction. So then I multiply by the common denominator, and that cancels here, and it leaves me 5s minus 3. That's a 5, and that's an s. And then over here I get the a times the s squared plus 4, and I get the bs plus c times the s minus 2, s plus 2. I multiply by the common denominator, and that's what I'm left with. And then I play this game to find the a, b, and c. You know, what you do is you let s equal something very convenient, like negative 2. Let s equal negative 2. It zeroes out that whole term very quickly. You plug in a negative 2, that's 4 plus 4, that's 8a. You're also plug in the negative 2 here. Negative 10, that's a negative 13. You just discovered that's negative 13. You just discovered that a is negative 13/8. Hang on to that thought. Don't lose it. In order to find b, I do a different game. I equate the coefficients of all the s squareds. I look for all the s squareds over on this side. How many s squareds do you see on this side of the equation? I see 0. And then I equate that to all the s squareds I see over there. And if I would FOIL it out, and I don't want to FOIL it out, but if I imagine it FOILed out, I have an as squared and I have a bs squared. And that's all the s squareds. So by equating coefficients of the s squared, I can find b, because I already know a is negative 13/8. If a is negative 13/8, I guess b is positive 13/8. All right, hang on to that. Now I know a and b. I'm going to go back to letting s be something convenient. Again, because of that quadratic factor, there wasn't really anything too convenient. That's why I went with this equating coefficients method here. But now I'm going to let s equal 0. Let's see, over here I'll have a negative 3. Right here, if I let s equal 0, I'll have 4 times a. By the way, I already know a. Why was 0 so smart? Because 0 times b is gone, although I know b. And I'm left with a 0, I'm left with a 2c. A 2c. So I can find c. Okay, little work here. That's a negative 3. That's a negative 13 over 2 plus 2c. I'm going to add that over here. That's negative 6 plus 13. I think that's 7/2 equals 2c. I think I just discovered that c is 7/4. I might have made a mistake, but probably not. Probably not. Negative 6/2 is 7/2. Right. Right. All right, dude, we did it. So instead of doing this Laplace inverse, I just decomposed the original fraction into this. So now I'm working on this Laplace inverse. Hang on, what the hell is it? It's a negative 13/8 over s plus 2, and then b 13/8 s plus the c, which is 7/4, all over s squared plus 4. So this, now I'm doing this Laplace inverse. I'll do it with you. Doing this Laplace inverse. I'm going to get rid of this, if you don't mind. This is good stuff, though. I try to avoid partial fraction decomposition. It takes time away from all my other fun activities. But I had to do it on this one. A linear factor and a quadratic factor, I had to do it. Here we go. This ain't going to be too bad. I know what he is. He's e to the negative 2t with a negative 13/8 in front of him. That's what he is. It's easy. I got some of these Laplaces memorized. This is s squared plus 4 with an s on top. That's cosine 2t. Is that what that is? That's cosine 2t with a positive 13/8 in front of it. The next one is a 7/4. See, I thought of it as two separate Laplaces. I'm sorry I didn't write it like that. But the next one is a 7/4 over this, which is a sine 2t. That's a sine 2t, but hold on. I need a 2 on top. So I pull the 7/4 out front, I put a 2 on top, then I divide by 2. I think I get 7/8 that way. Ta-da, ta-da, ta-da. That's pretty good, man. All right. Good luck on your quiz. That first part of the video should have helped you a little bit. All right. Keep working.